We're simply going to reduce fractions. That's all in the world we're going to do. So don't be thrown off by the fact that we have variables mixed in there with it. Let's ignore the variables for just a moment. Let's look at this and just say, oh, well, I'm dealing with 12 over 14. Well, if I'm dealing with 12 over 14, then what I really have is, well, let's see, 12 is divisible by 2. We divide that in 6 times. 14 is divisible by 2. It goes in 7 times. We have 6 over 7. Now what we also have, and you don't have to do this every time, I'm going to do it the first time, and you probably already know the shortcut anyway, but what we're going to do is write out all the x's. We have x squared, which really means we have x times x, and we have y. And then we also have x, whoops, it messed up, no. We have x, and then we have y cubed, which means we have y. Because. That was funny in my head. Okay, let's cancel out anything that we see in the numerator and denominator. Now I said anything, actually any factor that we see in the numerator and denominator. I'm going to use that phrase a lot. We need to cancel out factors. And we can really get in a habit of just saying, I'm going to cancel this thing out. We have to be careful because there are times we might be tempted to cancel something that's not a factor. That doesn't make sense yet because this problem is not conducive to that conversation. I'm just throwing that out there. Okay, let's cancel an x with an x because everything is multiplied because they're factors. We're going to cancel a y with a y, and that's all we can do. And so it leads us to the shortcut that you already knew. We still have 6 over 7. We have an x in the numerator. We have y in the denominator. That is y squared. Shortcut time. Again, you already knew it. 3, 1. 3 minus 1 gives me 2. Okay, 2, 1. 2 minus 1 gives me 1. So then the obvious question is, do I do numerator minus denominator, denominator minus numerator? I personally like to do big minus little, put it where the biggest one is. There are other ways. You could do numerator minus denominator. You may end up with a negative and you might have to move it. But personal opinion, I think this is going to be what works the best. So we're going to go to the next problem, which is hiding over here. There you are, next problem. Now this first component, this first fraction that's in this big disgusting mess is, oh, there's another problem hiding here. Let's slide. There we go. Now you don't even know it's there. This, I wonder how many more there are back there. This is actually the exact same problem you just did. So we're going to do it again, but we're going to combine it with this one. So whenever I multiply fractions, I multiply across the top and across the bottom. So just real quick, if I handed you 3 over 4 and I want to multiply it by 5 over 7, then it's super easy. 3 times 5, 4 times 7, done. That 28 got real cursive on you, but that's it. So you could say 12 times 49, x squared, y squared. You really run into a lot of situations in that kind of case where you have numbers that are much bigger than they need to be. So it's best to go ahead and reduce it from the beginning. Like reduce this from the beginning if you can. For example, if this would have been instead, and I'm just going to doodle here. If this would have been 40 and this would have been 9, I would say, oh, well, you know, I can reduce some stuff, and I'm going to say, oh, 5 goes into itself 1 time, 5 goes into 40 8 times, 3 goes into itself 1 time, 3 goes into 9 3 times. And I could reduce the individual fractions, potentially, not in this case, but I can also reduce numerator, denominator, anywhere as long as I have multiplication in between them. And that leaves me with 1 over 3 times 8, so 24. That's what that one would be. Let's jump back to this one. Okay, we have already determined what this one is. Let's do it again super fast. 2 goes into that, 2 goes into that, 7 times, 6 over 7. Subtract your exponents. 2 minus 1 is 1. You don't have to put that one. 3 minus 1, big minus little. It's going to go where the biggest one was. Whoops! 3 minus 1 is not 3, it's 2. Okay, that's the first fraction. Second fraction, we'll reduce that. 49 divided by 9. Let's see, 49 divided by 9. It doesn't reduce. That's 7 times 7, that's 3 times 3. That's not going to reduce. That one's a y, that one's an x. So nothing reduces here. I really wish it did, but it doesn't. And so we're kind of stuck. That's all we can do with the individual fractions. Now we're going to switch colors for fun, and we're going to cancel out as much as we can, not just in one fraction, but in more than one fraction. So that's not the problem. We will ignore it. Okay, let's cancel whatever we can. Let's look at the numbers first. I have a 6, a 49, a 7, and a 9. Okay, let's 6. It's 2 times 3. Oh, there's a 3 that goes into that. 3 goes into that 3 times. 3 goes into that 2 times. Lucky us, okay? Oh, 7 goes into 7 once. 7 goes into 49 7 times. Sounds good to me. We can also reduce some variables. Let's do that. Same situation where we are subtracting. So I could say 1 minus 1 is 0. I have no x's left. Technically, I have x to the 0. I don't want to say I have 0x because that's a different issue, but I have x to the 0. I have y to the first here. So 2 minus 1, well, 2 minus 1 gives me 1, so I have y to the first in the denominator. There's a whole lot of stuff going on here. Let's clean it up one more time. We're going to clean this up by just doing everything across the top, multiply everything. So 2 times 7. Now, what I didn't write was that when something cancels out, it goes into itself one time. And so I could put a little 1 right here. My math teacher did when I was in high school. She would say, oh, well, this divides into itself one time, and that's one time. And she'd say 2 times 1 times 7. Totally valid. It's a really good explanation for where those numbers actually go. So 14 in the numerator. And the denominator is 1 times y times 3. That's 3y. And we are finished with that one. That's all we can do. It doesn't reduce anymore. All right, let's drag this over. Let's see what we have. Oh, boy. We have division. So in elementary school, you learned that when you are dividing fractions, you really are going to multiply by the reciprocal. So we're going to take a moment and flip this over. Reciprocated is the mathematical word for it. We're going to turn that into multiplication. So 75a cubed b, 15a squared bc. Now, if you want to go ahead and start reducing at this step, you can. I didn't, but you could. It'll save you time later. But I didn't want to overwhelm you with this problem from the get-go. Okay, let's start reducing individual fractions, and then we'll reduce across fractions. So let me say that differently. Let's reduce individual fractions, and then we'll reduce across fractions. So here reduces with here, here reduces with here. Anything in the numerator cancels with anything in the denominator, as long as everything is multiplied. Okay, as long as we're canceling factors. So let's grab a green pen and start canceling. Let's reduce as much as we can. Let's see, 5 goes into 15 3 times. 5 goes into 75 15 times. Wait, something's, whoa, something. 5 goes into that 3 times. You know what? You know what? It does go 15 times. No, it doesn't. I'm having a massive brain fart right now. I really am. Yeah, it does 15 times. Okay, sure, we'll go that route. Here's where I got hung up there. I was like, 5 goes into that 15 times, and I can reduce more. You can reduce more. So sometimes you get to this step and you say, oh, I didn't reduce it fully. And that's what was happening with me. Like, I forgot how to divide for a second and forgot that 15 goes into 75 5 times. Catch what I just said. 15 goes into 75 5 times, which really means if I reduced what I already have further, 3 goes into itself 1 time, 3 goes into 15 5 times. I could have reduced it fully from the very beginning. I didn't. Oops. Okay, let's start canceling some other things as well. And the work gets a little sloppy, but we'll cancel some other things. 10, no, doesn't cancel with anything there. Switching colors just so we don't run everything together. Let's just deal with individual fractions first. So I'm going to cancel, let's see, 3 minus 2 is 1, so a to the first. And then b divided by b. b to the first gives you b to the 0, so those cancel. We're going to walk over here. There, short walk. And we can cancel these b's as well, so those cancel. And we have canceled every possible thing that we could cancel in individual fractions. Now, the work can get so cluttered at this point that you might say, how about we just stop, rewrite it, and then reduce some more. And that's what I'm going to do in this case. It does run the risk of a little more room for Scrabble error, like you're writing something too many times, too many steps, and you can run into some mistakes. But also, like I said, the work is really cluttered, so it's easy to kind of jumble things up. So next step, let's just cross the top, cross the bottom. There'll be more reducing. Numerator, 5ac squared. 5ac squared. Okay. Denominator, 1, don't worry about it. ca. 10. 1 times c times 10 times a, number first. A, C. Okay, things are going to continue to reduce here. I noticed the 5 and the 10, well, that reduces, so switching to green again. 5 goes into itself 1 time, 5 goes into 10 2 times. A divided by A cancels. Again, you could have done that here. You could have been like, oh, that's going to cancel with that one. Totally fine. 2 minus 1, I'm going to cancel that. It's going to give me C to the first. Final answer, in blue, is going to be 1C to the first over 2. C over 2.